Welcome to the session. In this session, I am going to talk about fuel cells, their classification, construction, and working of hydrogen-oxygen fuel cell. Fuel cells are the devices which convert the chemical energy of a fuel and an oxidizing agent into electricity. Fuel cells are a bit different from the normal batteries which we use in everyday life. Normal batteries we use different chemicals, different active materials as electrodes. And in a fuel cell, the chemical energy of a fuel and an oxidizing agent is converted into electrical energy. Now, commonly used fuels are hydrogen, natural gas, methanol, gasoline, etc. And commonly used oxidizing agents are air or oxygen. Fuel cells, they convert the chemical energy of a fuel directly into electricity without combustion. Fuel cell technology that provides an opportunity for creating eco-friendly portable power supplies which are capable of producing enough energy to run devices and motor vehicles. So normal batteries, they are used in various electronic devices, but mostly they are not used for running vehicles, motor vehicles. But the fuel cells, they provide an opportunity for eco-friendly portable power supplies. Okay, so normal batteries, they may be toxic or may not be toxic depending upon the battery. But the fuel cells, these are pollution free, mostly pollution free. They will not damage the environment. They are eco-friendly, and these can be used. Fuel cells can be used for running not only devices but also motor vehicles like buses, other automobile vehicles, etc. The working principle of fuel cells is common to that of normal battery. Conversion of the free energy, change of redox reactions at the electrodes into electrical energy. That is the working principle. This is common to normal batteries and fuel cells. And coming to the construction, fuel cell has two electrodes and an electrolyte, where at the respective electrodes, fuel and oxidizing agents are continuously fed. Fuel cells are always operated with continuous replenishment of the fuel at the electrodes, and consequently they doesn't require any recharging. When we are using the fuel cells, we have to feed the electrodes with the fuel and oxidizing agents. Hence, they does not require any recharging. We will be continuously getting power when we are supplying the fuel and oxidizing agents continuously. So, a fuel cell can be represented as fuel bar electrode bar electrolyte bar electrode bar oxidant. I mean, two electrodes we have. At the respective electrodes, we are feeding the fuel and oxidizing agent separately, and we have one electrolyte also. So this represents the fuel cell. Common chemical reactions occurring in the fuel cells are: fuel gives rise to oxidized product plus n electrons. This is the oxidation reaction which occurs at the electrode where we are feeding fuel. Fuel undergoes oxidation always. Next, another chemical reaction is reduction reaction, which is occurring at the electrode where we are feeding the oxidizing agent. So the reaction is oxidizing agent plus n electrons gives rise to reduced product. So these are the common chemical reactions occurring in the fuel cells. Uh, obviously, obviously, fuel undergoes oxidation and oxidizing agent undergoes reduction. Classification of fuel cells. Fuel cells are classified on the basis of their operating temperature. So there are three types of fuel cells. One is low temperature fuel cells, which are operated at a temperature less than 100 degrees centigrade. Second one, moderate temperature fuel cells, which are operated a temperature range between 100 to 250 degrees centigrade. And high temperature fuel cells, which are operated between 250 to 500 degrees centigrade. Generally, in the fuel cells, the electrode reactions are slow at low temperatures when we don't use a specific catalyst. Suitable catalysts, if we are not used, the electrode reactions in the fuel cells are generally slow, and the EMF of the fuel cells decreases due to polarization effect when current is drawn from the fuel cell. So when we start using the fuel cell, its EMF decreases due to the polarization occurring at both electrodes. So to improve the performance of fuel cells, proper electrodes and electrolytes are used, and also to make the fuel cell suitable for desired applications. Electrolytes having another classification of fuel cells based on the electrolyte which is used in the fuel cells. Fuel cells can be classified into 6 categories based on the electrolyte which is used in the fuel cells. The basic point we know is heat accelerates the chemical reactions rate, and consequently the rate of electrical current is also increased. Generally, electrolytes have their best conductance only within a certain temperature range. So, while constructing fuel cells or while choosing electrolyte for construction of a fuel cell, we have to take into consideration the temperature range at which the electrolytes work well. The 6 categories, 6 types of fuel cells are alkaline fuel cells, phosphoric acid fuel cells, molten carbonate fuel cells, polymer electrolyte membrane fuel cells, solid oxide fuel cells, biochemical fuel cells. So these are the 6 types of fuel cells which are named after the electrolyte used in the fuel cells. Merits of fuel cells. Fuel cells have some advantages over normal batteries. Let us discuss. Fuel cells have high efficiency of conversion of free energy of redox process into electrical energy. Normal batteries, free energy of active materials will be converted into electrical energy, and in fuel cells also the same. Free energy of the fuel and oxidizing agent that is converted into electrical energy. But here conversion is efficient. High efficiency of conversion we see in fuel cells compared to normal batteries. Next merit is silent operation. Fuel cells can be operated silently. The noise or the sound produced by the fuel cells is less when compared to the normal batteries during usage. Next merit, recharging of fuel cell is not required. So fuel cells are one type of primary batteries only, as recharging is not observed here. Continuously we are supplying the fuel and oxidizing agent at the respective electrodes, and continuously we will be getting the power. So no recharging is observed in fuel cells. This is one advantage of fuel cells over normal batteries. Next, less attention is needed. So fuel cells are not stored, as we have to supply the reactants, fuel and oxidizing agent, they are supplied only during usage, hence less attention is needed for fuel cells compared to normal batteries. Next merit, harmless waste products and eco-friendly. Most of the fuel cells, they are eco-friendly. The products which are produced in the fuel cells, they will not damage the environment, and so they are eco-friendly compared to normal batteries. Normal batteries also we have some eco-friendly uh, batteries, but comparatively fuel cells are more eco-friendly. Among the fuel cells, hydrogen oxygen fuel cell is the simplest one and also the most successful fuel cell. Coming to the construction of hydrogen oxygen fuel cell, it consists of inert porous graphite electrode thoroughly mixed with the finely divided platinum or 3:1 ratio of alloy of palladium with the silver or palladium with nickel. So this electrode acts as the anode. The same electrode is used as the cathode. So composition of both electrodes is same. The composition is it is made with graphite containing pores, and catalyst is used, that is platinum. Finely divided platinum is mixed with the graphite electrode containing pores. Or in place of platinum we can use 3:1 ratio of alloy, 3:1 alloy of palladium and silver, or palladium and nickel. So that can also be used as the catalyst in both electrodes. So the both electrodes composition is same, but we can recognize the electrode as anode or cathode depending upon the fuel or oxidizing agent which is passed through the electrode. If you are passing hydrogen through an electrode, that electrode acts as the anode. If we pass oxygen through the electrode, that will act as the cathode. So you can see in the picture. So this is anode. Hydrogen is passed through this electrode, anode negative electrode, and this is cathode, as through this electrode oxygen is passed. So hydrogen gas is passed through this inlet, and we have an outlet. Through this outlet, unreactive hydrogen gas will come out, and the product water molecules, I mean in the form of water vapor, will also come out here through this outlet. And this is the inlet for oxygen at the cathode, and this is the outlet for oxygen, unreactive oxygen. And we have electrolyte here. Electrolyte is a KOH solution. 25% KOH solution is used as the electrolyte. So both electrodes are connected through a wire, and here we have applied a load also, a bulb. Okay. So this is the construction of hydrogen oxygen fuel cell. Here hydrogen acts as the fuel and oxygen acts as the oxidizing agent. So we can represent this hydrogen oxygen fuel cell as hydrogen gas, carbon which is graphite, then platinum. We have double vertical line indicating the separation of electrode and the electrolyte. Electrolyte is 25% KOH solution, and double vertical line again indicating the separation of the electrolyte with the cathode, that is carbon, platinum and oxygen gas. So this is the representation of hydrogen oxygen fuel cell. And coming to the chemical reactions occurring at the respective electrodes, at the anode we are passing hydrogen, it undergoes oxidation. The reaction is 2H2 plus 4OH minus gives rise to 4H2O plus 4 electrons. So 2H2 hydrogen gas we are passing, 4OH minus, these OH minus ions they come from the electrolyte, they are consumed from the electrolyte and forming 4 water molecules and 4 electrons. The electrons are produced here at the anode. They will flow through the load applied and they will reach the cathode. So at the cathode, reduction reaction occurs. At the cathode we are passing oxygen plus 2 water molecules plus 4 electrons gives rise to 4 OH minus. So 2 water molecules, 4 water molecules are produced at the anode. From those 4 water molecules, 2 water molecules are consumed at the cathode, and also 4 electrons which have come all the way from the anode to the cathode. They are consumed at the cathode. So this is reduction reaction forming 4 OH minus ions. See, at the anode 4 hydroxyl ions are consumed from the electrolyte. At the cathode 4 hydroxyl ions are produced at the cathode. So no consumption of electrolyte here. Now we can write the overall reaction as 2H2 plus O2 gives rise to 2H2O. Hydrogen and oxygen are the gases, and water molecules are formed at the anode. Okay, so this is about the working of hydrogen oxygen fuel cell, and the standard EMF produced by the hydrogen oxygen fuel cell is 1.23 volts, but in actual practice we get only 0.8 to 1 volt. There are many factors which lead to the decrease of EMF produced by the hydrogen oxygen fuel cell. Hydrogen oxygen fuel cell is an attractive power source compared to gasoline powered engines. The reason is that hydrogen oxygen fuel cells are pollution free as they produce only water, and also they have the capacity to convert 75% of available energy into useful work, whereas gasoline powered engines, they convert only 25 to 30% of available energy into useful work. So because of these two reasons, hydrogen oxygen fuel cells are preferred to gasoline powered engines. Next, advantages and applications of hydrogen oxygen fuel cell. Hydrogen oxygen fuel cells are light in weight. They are pollution free. Because of these two reasons, these are extensively used in space vehicles like Apollo spacecraft, in submarines, in military vehicles also these are used. And one important advantage of hydrogen oxygen fuel cell is when hydrogen oxygen fuel cells are used by astronauts, they will be getting drinking water. So the water molecules which are produced in the hydrogen oxygen fuel cell, they are used as drinking water by the astronauts. These are the advantages and applications of hydrogen oxygen fuel cell. Next, disadvantages of hydrogen oxygen fuel cell are cost of the hydrogen oxygen fuel cell is high. Then that is one disadvantage. Next one is storage of highly flammable hydrogen is problematic. So hydrogen is a gas, its storage is normally difficult, and also it is highly flammable. So it is highly problematic to store the flammable hydrogen gas. And another disadvantage is lifetime of the hydrogen oxygen fuel cell is not accurately known. So this is about the hydrogen oxygen fuel cell construction, working, applications, advantages and disadvantages.